Everybody, welcome back to another fun and exciting Algebra 2 class. Today, we are going to be doing something that is sort of complicated, but I'm going to show you some ways that we can kind of simplify it just a little bit. And I think that by the end of the lesson, you'll probably have a pretty good idea of what to do here. It is on page 129 in your textbooks, and it is equations of the quadratic form. But this is what to do when you have something like this. You can look down here and I have x to the 6th minus 11x to the 3rd plus 18 equals 0. Now, in this case, we don't have a quadratic because we have it to the 6th power. Wow, interesting. So what we want to do to this is we want to take this term right here and we want to turn it into a square. What does that mean? Well, here's what it means. We would take this, and instead of it being x to the 6th, we would say this is x to the 3rd squared. Okay? It's the same thing. We didn't change anything because, look, what is x to the 3rd squared? That equals x to the 6th, and that's the same thing. So we're not changing anything by doing that. What are we doing? We're turning it into a quadratic equation. That's what we're doing. Minus 11x cubed. And we could say this is to the 1. Okay, again, we're not changing anything. Why did I make this to the 1 power? Because I want that to be my linear term. That's going to be the x with nothing. And you'll see how this works out in just a second. Plus 18 equals 0. Now notice I didn't change this one either because everything to the first power is just itself. 6 to the first power equals 6. So I didn't change anything by putting it to the first power right there. Okay, it's still the same thing. I just put it to the first power. Now I have a quadratic equation. There's my quadratic, there's my linear, and there's my constant term. So there's my a, b, and c, and equals 0. So I have a quadratic equation right here, and I didn't change the value. Notice all I did with this one is I turned it into a square. That's it. This is exactly the same thing, but I changed its exponent to 1 instead of an exponent of 3, and that's so that I could have a quadratic. Now, this is where the little tricky part comes in. This is where the magic happens right here, okay? This is where you kind of gonna do something. It's like a little switcheroo, and it's going to all work out, okay? What we say is we come down here and we say, okay, this right here, instead of being x to the cube, let's make it, let's say that x to the cube equals, and you could make it any variable you want. The book makes it u, okay, which is fine. So wherever we see an x to the 3rd, we are going to substitute in a u. So a u is going to go right there, and a u is going to go right there. Why? Well, you'll see in just a second. But again, we're trying to make it as easy to solve as possible. Okay, so everywhere we're, again, trying to make it a quadratic equation. So everywhere that we see an x to the 3, we're going to put a u. So u squared. Look, there's our square. We keep the square there. Minus 11u to the 1, or just 11u, because what does the u equal? U equals x cubed. Well, there was an x cubed there, but we substituted in the u instead of the x cubed. Plus 18 equals 0. Now, look at what we have here. We have a quadratic equation. Now, it has the u in there instead of the x. I mean, if you wanted to, you could put any letter in there. It doesn't matter. You're going to get the same thing. What's one way to solve these? Well, by factoring. We could factor that. Is it factorable? I don't know. Let's try it. Look, we have a minus here and we have a plus here. So our signs are going to be minus, minus. That's going to give us a plus and a minus. And look, 18, what's our factors? 1 and 18, does that give us 11? No. 2 and 9, does that give us 11? Yes, it does. 2 and 9. That was factorable. So there we go. There's our factors, and remember, they both equal 0. We'll set them both equal to 0. So once you set these both equal to 0, you're just going to solve them out. So we're going to add 2 to both sides here, and we're going to get u equals 2. We'll do the same thing over here. We'll add 9 to both sides, and we'll get u equals 9. Done, right? Solved. Good. No, not quite. We did something earlier, didn't we? We substituted x cubed in for u. Well, what we have to do right here is we have to substitute it back in. In other words, we have to say now it's x cubed equals 2. We're getting rid of the u. We're taking the u back out. And then we're going to say x cubed equals 9. And now what we're going to want to do is we're going to want to solve for both sides. We're going to cube root both sides. And we're going to get, this is going to cancel. We're going to get x equals the cube root of 2. And over here, we're going to cube root both sides. Don't forget it's a cube root, not a square root. And we're going to get x equals the cube root of 9. And then we're done. That's solved. Okay? So that's the finished product right there. If you want to check those, and it's good to check those, because remember, we're looking for extraneous roots, what we would do is we would plug that back into the original equation. Most of your calculators will handle that right there with the cube root. You should be able to know how, you should know how to do that at this point. If you don't, you're in Algebra 2, you should be able to figure out your calculator. Do the checks on your calculator, it'll be so much faster. Plug that in right there for the x cubed, okay? So wherever the x is, or where the x cubed was, so now we got it for x. So right here, we're going to put our, actually we have to solve it both ways. We have to solve it once with the cube root of 2 and once with the cube root of 9. We just plug that right back in there, put it in a calculator, equals, and it should equal 0. If it does not equal 0, what does that mean? Not a solution. It's extraneous. What happens if it does equal 0? Then we're good. That is an answer. That is a solution, and we can move on. If you look there in your book on page 130, both of those answers check, and we can move on. Now, one thing that they do there, which is interesting, is they do something when they plug it back in, and I'm just going to show you this. This is for your enjoyment right here, but if you're putting it into a calculator, you won't have to do this. But when they plug that in, they don't plug it in like this. Okay, it's too challenging to do the math with the square root signs. So what they do is instead they say that this is 2 1/3. Where'd that come from? Well, they turned the exponent into a fraction. Remember, there's a 1 exponent there. So this is our denominator. The index is our denominator. The exponent is our numerator. So it would be 2 1/3. So they plug 2 1/3 back in. And that works out a little bit better. So remember, once we've learned something in algebra, once we've covered it in a lesson, then you have to know it for the future. And this is one of those places where this comes in very handy. What would this 9 be? Well, it'd be 9 1/3. Okay, so you'd plug those back into the original equation, and you could even give me this as your answer. You could give me 9 1/3 as your answer, and that would be a fine answer. So either way there is fine. All right, so now what would you do in this case where I have the x to the 1/2 minus 3x to the 1/4 minus 4 equals 0? Well, again, what we're trying to do is we're trying to get this, we're trying to take this to a quadratic equation. Now, technically, this is a quadratic equation, but it doesn't look like our standard form. So what we want to do is we want to get that into standard form. Well, how would we do that? Well, we're going to turn this into a square. So we're going to have x to the something squared. How would I square this? In other words, What is that? Well, you kind of got to think through it, but it's x to the 1/4. X to the 1/4. How did I do that? Well, what you do is you just square both of these. 1 times 1 is 1, 2 times 2 is 4. So I just squared both of those, and I got the 1/4. Another little shortcut, let me tell you a little trick right here, is typically it's going to be whatever this middle term is. Okay. If you look back here at this one, the middle term was 3, and we took it to a 3. Okay. And that's just going to be the way that these work out for you. That's not necessarily, that's like a little shortcut. It's kind of like a little trick. And it could be something different. But the ones that the book's going to give you right here, you probably just need to look at that middle term and see what it is. And that's probably what's going to end up here. The middle term is going to end up there. Why? Just because that's the way these work out. So then we're going to want to do the same thing here. We're not going to change this one at all. That's just going to be the 1/4 to the 1 minus 4 equals 0. Now we come over here and we say, okay, I want to substitute this out. I want to get rid of, I don't want to work a question out like that. Are you kidding me? With a 1/4? No way. And so let's substitute it out. Let's say u equals, well, let's say x, I'll put it the other way, x to the 1/4 equals u. Okay. We're just going to substitute u in everywhere that you see an x to the 1/4. We're going to put a u in there. All right, so then we end up with this right here. U squared minus 3u minus 4 equals 0. Well, this looks a lot easier. You're right, it does. So now we say, can I factor this? And good news is we can factor this one. So we're going to get u. Let me change the color here. We're going to get u. The signs are minus minus, so we're going to get a minus plus. And they're both going to equal 0. Don't forget that. That's important to have every time. And what two things? So one is positive, one is negative. So we're going to have a positive 1 and a negative 4. That's going to give us our negative 3 in the middle. Okay? So there's our factors. And now what we need to do is we need to send this over here. So we need to add 4 to both sides. So we get u equals 4 positive, minus 1, u equals negative 1. Now what we'll do is we will substitute back in. We'll go back up and get this guy right here, this x to the 1/4. And so now instead of u, we're going to say x to the 1/4 equals 4. And x to the 1/4 equals negative 1. Well, how you solve that is kind of, it's up to you. What I would do there is I would use my calculator. Okay, so if you don't have your calculator, you don't know how to solve it using the calculator, whatever, you just want to know how to do this. Well, one of the principles in math that's always true is you can eliminate things by doing the opposite to them. So if we want to eliminate this fraction right here, I can do the opposite. What is the opposite of 1/4? Well, it's multiplying by 4 or 4 over 1. So if I multiply that exponent by 4 over 1, what happens? Well, this all cancels out, and I get x, or x to the 1, or just x. That's all I need. But if I do it to this side, I also have to do it to this side. I have to multiply that by 4 over 1. Or 4 over 1 is the same as saying to the 4th. What is 4 to the 4th? Well, you would get x equals, you could do that on your calculator, 4 times 4 times 4 times 4, and you would get 256. X equals 256. So that's how you would solve that one out. Over here on this side, we would work it the same way. And we come over here, and it would be times 4 over 1. And we would say times 4 over here. Or 4 over 1. But this cancels. We get x equals, well, this one's interesting because we kind of need to do this one. Or you could do it on your calculator. Negative 1 times negative 1 equals 1 positive. Okay, times negative 1 equals negative 1 times negative 1 equals positive 1. All right, so that one actually comes out to a positive 1. So if you do that on your calculator, it'll give you positive 1. If you do that in your head, the first time that you do it, negative 1 times negative 1 is going to give you positive. You do it again, it gives you negative 1. You do it the fourth time, and it gives you a positive 1. One way to remember that is that when the exponent is even, 2, 4, 6, 8, it's always going to give you a positive. When the exponent is odd, 1, 3, 5, 7, 9, okay, any odd number, it will always give you a negative, okay, and that's just an interesting thing. So if negative 1 to the 1 power, what's negative 1? Negative 1 to the third is negative 1. Negative 1 to the fourth, because it's even, is a positive 1. All right, so there are our two answers. Well, this one, when you plug it back in to the original, plug it into your calculator, it is going to tell you that the 256 works. 0 equals 0. This one is correct. When you plug in the 1, it's going to tell you that that is not correct. You end up with like negative 6 equals 0. Okay? And when you get that, that's extraneous. And so that solution does not work. So the only solution for this one is the 256. Okay? All right, and that's in your book on page 131. And then the next one, there's another example on 132. It's just more of the same thing. And then there is another example on 133. Basically the same thing again. So just little different ways of doing it, but they all end up working out the same way. You substitute in, solve it out, and you end up with an answer, with two answers typically. And then check them, and then sometimes they'll be extraneous, and sometimes they'll work out. All right, well, that's all I have for you today. Hope you enjoyed it. Hope you learned something. If not, make sure you rewind that thing, check it out again, and see if you can figure this stuff out, okay? We'll see you later. Bye-bye.